Video number 3 and last video on the lecture on pollution, and we're going to talk about treatments. How can we take care of any issues regarding pollution? We can in fact treat pollution following a couple of steps. The first one will be what we're calling characterization, knowing what we are dealing with, knowing the quantity of it, and also quantifying it and qualifying, putting a name into it. The second one will be to look at where is that pollution is coming from, trying to find the origin, so we might be able to shut it off at least. Then we want to contain it. So we want to make sure that the pollution doesn't spread anymore. And then once we have done those 3 steps, we need ideally to be able to remove it, to take it away, to take it out from the place where the pollution happens. And final way would be to remediate or to treat it. That means to move from that pollution to something that is not polluting. And so that can be involving physical processes, chemical processes, or biological processes. And we'll be looking at each of those steps one by one to explain how we're dealing with pollution treatment. And we will rely on the lecture prep I've been asking you to do before watching this video, which is on the study case of the Kesterson National Wildlife Refuge, which happens to be not so far from Merced, as you can see from the map. And that's lecture preparation. As in this lecture preparation, I asked you to watch a video talking about what has happened. Also, there was an article to a Wikipedia page giving you some more information about what has happened and about the treatment of that pollution on the site, just to set up the reason of why there was some action being done. Is during the 80s that that's a wildlife refuge were having huge pollution site on the soil and water that lead to deformities and high mortality in the waterfowl population. All ducks and migrating birds were in fact declining in terms of reproduction because of local pollution. So if you haven't done yet the lecture prep, make sure first to do it. And I will conclude with this lecture prep on applying everything that we've done through that video. So we say that the first step to deal with pollution is to know with what we're dealing with. And so that's what we're calling characterization. The first step, characterization. That can be like doing some soil sampling or water sampling or air sampling. And the idea is to get a sample and being able to identify that sample by, for example, using some instruments to do it, defining what is a sample, how much of it we have, what's the concentration, estimate the number of it, and then also giving us an idea of where do we find it. So we can start kind of mapping also the expansion of that pollution. Then when we have all of this information, we need to look at the origin of the pollution. We can have 2 cases, what we call point source or non-point source. Point source will be to an origin that we know clearly, we have clearly defined. It's coming from a leak, potentially from maybe a wastewater treatment, or maybe some release from a factory. So we have a clear idea of where it's coming from. That's a point source. A non-point source is where the sources are not clearly defined. It can be runoff from from an agricultural region. It can be coming from different kind of crops, or it can be also some pollution coming from cities. And so it's difficult to have an idea of where it's coming from, especially when it's coming during a storm water runoff or during some very heavy precipitation. It makes everything very tricky to figure out. So ideally, a point source is easier because you know exactly the source of it and you can treat, you can close the valve of the pollution. A non-point source is more difficult to deal with and to make sure that you're avoiding pollution coming from that non-point source anymore. Once you have defined the characterization and the origin, you will try to contain the pollution. Different techniques can be done. Mostly, we might be using physical barrier, depending on the pollution. Not every pollutant will react the same way with the barrier we are creating. We might use concrete to make what we call a slurry wall. So if you have the pollution on this side, you're building a wall made of concrete that can contain that pollution. That can work. We can, if the pollutant is solid enough, we might do what we call sheet piling, in which we just have some wood or metal sheets that will be in fact containing the pollutants in itself. If the pollution is a substance that doesn't like to mix with water, such as oil, gasoline, for example, we might just do some barrier that will be just containing water, because we know that the pollutants in itself will not mix with water. And so that's a way to make sure that that we are containing that pollutant with, in fact, a fence of water. So we're making sure that the pollution doesn't go away. Then we can finally try to remove it, if that is possible. Not every time it's possible to remove it. Sometimes we are stuck with the pollution because it would be too expensive to remove. But if we can do it, we go for it. If the pollution is maybe some water pollution, diluted pollution in water, we might be able to pump it. And so you imagine that you have some sludge like right here, they're able to pump it and to take out the pollution. We can be doing some excavation, or we can try to contain it and to move those containers to another place. That's kind of the idea, moving the pollution where it can be treated. The treatment can happen on site if we were not able to move that pollution, or it will be happening to another site of treatment, and that will be our next step, where we want to detoxify hazardous waste, making our pollution not hazardous anymore. We have 3 methods for it, remember: physical, chemical, and biological. Why do we use those 3? Because they are responding to specific conditions. The physical part is mostly where we are able to take out easily the pollutant, because we can just dig and pump it, for example, as we saw before. And we might be able to either contain it in the container and we let it this way, or we might burn it out. Not the best solution, as you can see, but it's the physical removal of treatment of waste. So it doesn't really clean it up as well, as good. Chemical will be, of course, using some chemical reaction to change the status of the pollutants. And so we will be using some specific chemical that chemists knows react well with the pollutants to make it less harmful. So it's to reduce the potential harmfulness of the pollutants. To do that, I mean, we also can use a treatment wall, which are specific walls, such maybe sometimes concrete or so, but that will allow to filter. If your pollutant is liquid, it will go through that wall and it will filter, and all your pollutant will stay within the wall. That's another one that is in fact mixing physical and chemistry at the same time. The good point of physical and chemical, it's fast, but it tends to be expensive. I mean, imagine, because you have to bring a lot of things, you have to use a lot of resources, so it tends to be expensive. Another downside is, as you may guess, it's not sustainable. It's not really good regarding the environment, because you're impacting on the soil, potentially, you're changing the structure, you're changing the chemistry, the biology. I mean, locally, you're damaging the place. So you can use biological processes, which are of 2 types. Bioremediation. For bioremediation, you're using bacteria or enzymes that will be able to digest your pollution. So you may be able to provide those bacteria or enzymes by just, you have some people, in fact, specific with specialty on that. They will bring those bacteria and enzymes on the soil that is polluted, and those will be digesting that pollution. Or the soil in general, you will let the soil doing it because it contains already the correct bacteria and enzymes to do it. The other ways is what we call phytoremediation. And for that, you're using plants that can be natural or sometimes also modified genetically to convert the pollution into something less pollutant. It will absorb the pollutant, it will filter it, it will remove it from the soil, and potentially just accumulate the pollution within the tissue of the plant. This is way cheaper, but it takes longer. You have to be patient, but at least it's a sustainable approach. So let's look quickly at both of bioremediation and phytoremediation, because they are the most sustainable one to deal with. If we're using bioremediation, we will be using microorganisms such as bacteria, enzymes to break down, to digest the pollutants to something less harmful. And so it works pretty well with a lot of natural pollutants, such as maybe salt type of pollutants or kind of some metal type of pollution, but anything that tend to be human created tend to be more difficult to deal with. An example would be plastic. We have issues to be able to use bacteria and enzymes to destroy the plastic, in particular for the one in the seas. However, they'll be able to identify a couple of enzymes that seems to break down plastic now and might be helpful for that purpose, but it's still under study. We have 3 subcategories of bioremediation. We have what we call bioattenuation, where we just close the site and say, okay, nature will be doing it. We just let it happen. So no action, just letting nature doing it. And so little by little, the soil will be cleaned up thanks to its own microorganism. We can do what we call biostimulation, where the only action we'll do, we still close the place, but we will be adding some fertilizers, water, to provide food for those microorganisms to be able to destroy, to convert that pollution. And then bioaugmentation, it's a step where you're adding this food, but also you're adding some strain of bacteria, some microorganism, you're completing the food web in some way by providing those microorganisms to make sure that they are digesting the pollutants. So that's for bioremediation, the use of microorganisms. The bioremediation is to use plants. And so one way is plants are pretty good for all of those pollutants, natural one and also human-made pollutants, such as pesticides, solvents. I mean, you see hydrocarbons, what we call PHA, etc. And so what happens is you're planting your plants through the roots. It will absorb this pollutant. It will keep the pollutant as bioaccumulation, and it will filter by releasing whatever water, air, etc. And at some point, what you can do is harvesting the plant and disposing of this plant. This plant can be after composted, incinerated, and it is a more natural way to deal with. However, again, I mean, the problem is it's more natural, but it takes way longer for that to happen. But using plants and tree phytoremediation is one of the best ways to approach the treatment of pollution. It happens through different filtering process. First, the absorption usually happen through the roots. It will accumulate within the tissue, but as you can see, there is a lot of places of filtration that can happen through the roots, through the tissue in itself, through the leaf when there is a release of the gas through the leaves, and also accumulation of the pollutants through inside of the plant in itself. Again, it has a lot of advantages. It's definitely more natural, but it is a very slow process. It's only effective when you have a superficial pollution, not too deep. And then you may have issues of impact on the wildlife, for example, that may hit those plants. So you want to make sure that there is nothing like that happening, because otherwise you start having bioaccumulation in your herbivores and carnivores on the top part of your pyramid. So it wouldn't be a great thing. So to end up, I'm going back to the study case, which was in fact the lecture prep in which you had information. If we look at the case of the Kesterson National Wildlife Refuge pollution, we can find this information. Let me show everything. The pollutants was in fact a selenium, and from the website, Wikipedia website, they give a concentration which is 300 micrograms per liter in 1983. To be honest, I mean, concentration doesn't really mean too much to us. It's equivalent of 9 tons, so a pretty big amount of selenium over that region. The origin was in fact wastewater coming from agricultural site on the west side of the valley, that naturally this wastewater coming from the coast range was naturally rich on selenium, but this water evaporated, letting this huge amount of salt accumulated over time, creating this local pollution. What did they do to contain it? Well, they closed the reservoir and make sure that no more drainage water, no more water would come into the wildlife refuge. So they had to close it down and making sure that there was no more resources coming into it, trying to block it from anything else. They didn't remove it except some vegetation, some part of the vegetation, just to make sure that we were not impacting on the wildlife and try to have the microorganism to work. And in terms of remediation, they did two types. They had phytoremediation site, one with some grassland vegetation, one with some annual plant species, and they had a bioattenuation site where they mostly, again, I mean, that was bioremediation, and they just let the site open and let it rest. And it took about 20 years and something for the site to recover and to be mostly free of its pollution. So it took some long time, but it was a successful story that cost less money than it would have been if we would have done it through physical removal or chemical removal, without speaking about the bad impact on the environment that would have been created. Because at least nowadays, the Kesterson refuge is still a refuge for a lot of species, as it has been in the past. With that, we are done with the lecture of the day, and so I'll see you very soon to talk about waste and our product, how to make product better to avoid to dispose of them. See you very soon. Bye, everyone.